and we connect the cells in series, the group of cell that will make a battery, the voltage of the battery is equals to the sum of the EMF of each cell. Like if I was having a 6-volt cell connected to 2-volt cell, what will be the total voltage or EMF produced by this battery, the combination of the cell? So if we have 6 volts and 2 volts are connected in series, the total will be 8 volts. Same thing in this question, what they're saying, they mention that you have cell each of voltage E, like the first cell is having a voltage E, EMF E, the second cell is also having EMF E, and the third cell is also having EMF E, and they are connected in series. So when they are connected in series, we need the total. So how to get a total? So it will be E plus E plus E. So when we add them, what we will get? We will get 3E. So the answer for this part is equals to 3E. Now the next part, the current in the battery is IB. The current in W1 is I1 and the current in W2 is I2. So first I'll draw a circuit, how this circuit will look like, because in this circuit you have 3 cells which are connected in series. You have 2 resistors W1 and W2 which are connected in parallel, and the resistance of W1 is known, that is 16 ohms, and the resistance of W2 is also known, that is 4 ohms. So this one was W2. We already calculated W2, we calculated, W1 is already given in the question. The beginning of the question, start of the question, this value is given, that it was 16 ohm. And W2 we already calculated here in part B1. So this is how the circuit look like after connecting the 3 cells in series to 16 ohm and 4 ohm resistors which are in parallel to each other. So the total is 3E. Now they're saying the current in the battery is IB. The current which is coming out from the battery is IB. And the current which is passing through W1 is I1. And the current which is passing through W2 is I2. So as we know, in parallel circuit, the current divide between the branches. Which one will be the greatest current, IB, I1 or I2? Which current will have the highest value? First thing. IB will be higher than any, because IB is actually divided into I1 and I2. So definitely IB will be much larger as compared to I1 and I2. So either this kind of option can be right or this one. So we have to take only one box. Then when we compare whether I1 will be more or I2 is more, the relation between resistance and current in parallel circuit, they're inversely proportional. The one which will have smaller resistance, greater amount of current will pass. So which current will be higher, I1 or I2? Which current will be higher? The relation between the resistance and the current inversely proportional. So I2 will be higher because smaller resistance, so greater amount of current will pass through this 4 ohm. This is having high resistance, so small amount of current can pass. The correct answer for this, IB is greater than I2 and I2 is greater than I1. Is it clear discussion? Then another question. Figure 7.1 shows a circuit diagram that include a component X. State the name of component X that we will discuss in a circuit components, but I will write just the name. This is called a thermistor. You have to learn the symbol for different circuit component that we will discuss in the next session. So here I'm writing the answer directly. So component X is a thermistor. Now, the electromotive force of the battery is E. So battery is having an electromotive force E. The potential difference across the 30 ohm resistor is V30. So the potential here they say V30. V30 does not mean it has 30 volts. It means voltage across 30 ohm resistor, and the potential across 20 ohm resistor is V20, and the potential across component X is Vx. State the equation which relate Vx to V30. How we can relate Vx with V30? X and 30 ohm are in parallel. So if they are in parallel, what will be same for them? The voltage will be same. So if voltage is same, we can say V30 is equals to Vx, or Vx is equals to V30. Is it clear? Because in the question, they ask state an equation. Equation means it should involve an equal to, which relate Vx with V30. Because they are in parallel, so what is the voltage across the 30 ohm resistor? That will be same as voltage across component X. So I can say the voltage of component X will be same as voltage of 30. Then state equation which relate Vx to E and V20. So how we can relate? Because what happened if the total voltage is E, the voltage at this point is X and voltage at this point is 20. Because they are in parallel, so they will have the same voltage. So V30 and Vx are same. So how I can relate the equation? So I can say E, the total voltage, is equals to voltage across X plus voltage across 20. Is it clear? Because they will, if I use a number for understanding, like if I say this is 20 volts, if this one is 5, this will also be 5. And what about voltage across 20 ohms? So that will be the remaining voltage, that is equals to 15. So how we relate, basically we say 20 is equals to 5 plus 15. Or in terms of variable, if the total voltage is E, the voltage across X is Vx, and voltage across 20 is V20, voltage across 30 is V30. But because these two voltages are same, so we can take any value. So I can say E is equals to V30 plus V20. But in the question they say relate or write an equation which relate E and V20 with Vx. So we need V30 here, and we know V30 is also equal to Vx. So we can say the total voltage EMF is equals to V20 or Vx plus V20. Is it clear? The second equation. In the next part, The EMF of the battery, now the numbers are given. The EMF of the battery is 6 volts and the resistance of component X is 15. Calculate the total resistance of the circuit. The EMF, the voltage is 6 and the resistance of X is 15. So this resistance is 15 ohms and the total voltage is 6. Now, what is the combined resistance of the circuit? But first, before finding the total, because this is a combination of parallel and series, first I should find a parallel combination. The combine of this parallel. What is the combined resistance of these two? 30 ohm and 15 ohm. So that will be 30 product divided by sum. So 30 multiplied by 15 divided by 30 plus 15. What is the answer? 30 multiplied by 15, that's 450 divided by 45. So 450 divided by 45, that is equals to 10 ohms. So the combined resistance, of these two resistors which are connected in parallel, that is equals to 10 ohm. And 10 ohm and 20 ohm are now in series. So if they are in series, what will be the combined resistance of the whole circuit when we replace them by 1? Because they are in series, so it will be 10 plus 20, that's 30. So the combined resistance of the circuit is equals to 30 ohms. So the combined resistance is 30 ohms. So you have to show, it's of 3 marks. So you have to show how you work out, what formulas you use. First you find the resistors in parallel, which is the product divided by sum. So it was 15 multiplied by 30 divided by 15 plus 30. And that you got 10. And then in series, the total will be 10 plus 20. That's why it is 30. The ammeter reading. So where the ammeter is connected, the ammeter is to give the total current in the circuit. Current is entering, conventional current from positive to negative, but we know the total current which entered the circuit is always same as the total current which leaves the circuit. So basically we need a total current. If we need a total current, we need total voltage and we need total resistance of the circuit. So what is the total resistance of this circuit? In the previous part, we work out the combined or the total resistance. That the combined or the total resistance is 30 ohms. So we have the formula V is equals to IR. V is a voltage, that's 6. I is the current, we don't know, and the combined resistance is 30. So it will be multiplied, I is multiplied by 30, other side it will divide, so it will be 6 divided by 30. So 6 divided by 30, what's the final answer? 0.2 amperes. So the current which will flow out from this, that is equals to 0.2 amperes. The temperature of component X increase, state and explain what effect will have on ammeter reading. This part is related to circuit component, so we'll not discuss now. After discussion or explanation of circuit component, I will explain what will be the effect on the reading of ammeter. In the question, another question, a battery is made up of 8 cells which are connected in series. So there are 8 cells which are connected in series. The EMF of each cell is 1.5. One cell label 1.5. Calculate the EMF of the battery. What will be the total EMF of the battery if EMF of one cell is, so it will be 8 multiplied by 1.5, that is equals to 12. And you can see it's a 1 mark, so you don't have to show working. Directly you can write the answer here. For the next part, calculate the energy transfer from the battery in 40 minutes. And see the weightage, the question, it's of 4 marks. So means you have to, when it's have 4 marks, it means you have to either a unit conversion is there or you have to use 2 or more formulas. To calculate the energy, what we need power and we need time. And to get the power, so to calculate the energy, we need power and time. And to calculate the power, because the power is a product of voltage and current, or we can say P is equals to VI. So first we will try to find the power, which is P is equals to VI. We know the voltage, that was 12, but we don't know the current. So we cannot find the power. Now to find the current, there is another formula. We have V is equals to IR. Or if we need current, the current will be voltage divided by resistance. The voltage is 12, the voltage of a battery, not cell, divided by total resistance. What is the resistance connect? A 8 ohm resistor is connected. So 12 divided by 8. What is the answer for 12 divided by 8? That's equal to 1.5 ampere. So we have, this is not the final answer. This is the answer for the current. So 1.5 ampere is the current. So now we'll find the power. 12 multiplied by 1.5. That's equal to 18. So we'll have the power, which is 18 watt. But we don't need power. Finally, we need energy. Energy is power multiplied by time. So power is 18. Time is 40 minutes. But time, the SI unit of a time is second. So it should always be in second, which is 2400. Or you can all directly multiply by 60. What is the final answer? 18 into 40 into 60. 43,200 joules. Is it clear, this part? That is the reason why you find the weightage of this question, the distribution of the marks. It's a 4, because when it is a 4-mark question, it means it involves either a unit conversion or using different formulas. As we use different formulas, we work out current, then we work out power, and then we work out energy. So energy is power multiplied by time. To get the power, we need voltage and current. Voltage is there, but we don't know current. We can find the current using a formula V is equals to IR, or I is equals to V over R. So after getting a current, we'll multiply current with voltage, we'll get power, and we'll multiply power with time, we will get energy. Describe the energy changes that take place during the 40 minutes. Again, this is a similar question which I discussed with you. Like if you have a battery and a battery is connected to resistor, which is 8 ohm. Which form of energy is there inside the battery or a cell? So cell is having a chemical energy. Then what happened to that chemical energy that produces the chemical reaction, produces charges, so it will have electrical. And that electrical energy, when it passes through the resistor, because the resistor, they try to oppose the motion of the charges, so it will produce, or it will become hot, or it will produce heat energy. So energy transformation is from chemical to electrical to heat. Another question related to the circuits. Figure 9.1 shows a circuit with three 1.5 volts cell. What is the total EMF of the battery, or total EMF of the cells, or what EMF of the battery? It's the same thing. What's the answer? Each is 1.5 and there are three. So 3 multiplied by 1.5, that's equal to 4.5. So the total voltage which is produced here is 4.5. In the second part, the total resistance. What is the total resistance when two resistors are connected in parallel? 3 ohm and 6 ohm are in parallel. So if they are in parallel, it will be product divided by sum. So yeah, that's right. It will be 6 multiplied by 3, which is 18, divided by 6 plus 3. So 18 divided by 9, that's equal to 2 ohm. So EMF was 4.5 and this one is 2 ohm. 3 marks. So you have to show your formula you use, your working, as well as the final answer. The current in 3 ohm resistor. The current in 3 ohm resistor, as we know, if this is a 4.5 volt and only the components which are present 3 ohm and 6 ohm and they are in parallel. So in parallel, they will have receive the same voltage. So what will be the voltage across 3 ohm? So that's 4.5. And what is the voltage across 6 ohm? So voltage across 6 ohm will also be 4.5. Why? Because they are in parallel and there is no other component. But for example, if there was another component which is connected here, it can be a bulb, lamp, or a resistor, any component connected here. So in that case, if this was a 4.5 volt, even though they are in parallel, but they're not parallel to battery, there is another component which is next to them in series. So total voltage, if for example, if 2 volts drop here, remaining 2.5 volt will be across 3 ohm and 2.5 volt will be there across 6 ohm. The total will be 4.5, but they will not have the same voltage as voltage of the supply. But because in this circuit, the two resistors are in parallel and there is no other component, so they will receive the same voltage as a supply. That is why both will receive 4.5. So if I need the current in 3 ohm resistor, I need a voltage and I need a resistance. So we have the formula V is equals to IR. So V is the voltage, that is equals to 4.5. I is a current which we don't know, and R is a resistance, that is 3. 3 is multiplied, other side it will divide. 4.5 divided by 3. What's the answer? 1.5 ampere. So the current which is flowing through, that is 1.5 amperes. Now, state using the letter in figure 9.1 how you would connect an ammeter to measure total current in the circuit. So where we will connect an ammeter to measure the total current in the circuit, and use a letter in the figure. How would you connect? You don't have to draw, you just have to mention an ammeter to measure the total current in the circuit. So two letters you should use, like will connect between A and B. You can connect between A and B, or you can connect between G and H, anywhere. But you have to yeah, G and H, because the total current which enter is equals to total current which leave. So the current which enter the circuit will be same as the current leave. So you can mention G and H, or you can mention B and A, or A and B. So connect between, you can mention between G and H or A and B. Voltmeter to measure a voltage across 6 ohm resistor. 6 ohm resistor. If we want the voltage, where I should connect a voltmeter? Here you have multiple answers, because look, if I connect between E and F, I will get the voltage. Even I connect between B and G, I will get the voltage. Even I connect between C and D, I will get the voltage. Why? Because they are in parallel. Or even I connect between A and H, I will get the voltage. So this connecting a voltmeter to measure volt, because they all have the same voltage, that's why I can connect anywhere. Is it clear, this part? Figure 9.1 shows a symbol for 12-volt battery. Two lamps are connected. I want everyone to use screen annotation to draw the circuit. Two lamps connected in parallel. Using a correct, complete the diagram. Use screen annotation to complete this. So one of these lamps having a resistance of 6 ohm, and calculate for this lamp a current, because what they mentioned, the two lamps are connected in parallel. So if two lamps are connected in parallel, one of the lamp is having a resistance of 6, and if this is a 12 volt, so same 12 volt will be there across that lamp. Calculate the current. So what will be the current in this lamp? So we will use the formula V is equals to IR to calculate the current. So V is equals to IR. V is a voltage which is 12. I is a current which we don't know, and the resistance of the lamp is 6. So 12 is 6 is multiplied, other side will divide. So 12 divided by 6, that is equals to 2 ampere. So 2 ampere is a current which is moving through this. Then we need a power. To calculate the power, we need P is equals to VI. So we need the voltage and we need a current. Voltage across the lamp is 12 and the current we already worked out is 2. So 12 multiplied by 2. What is the answer for that? 12 multiplied by 2, that is equals to 24 watts. Then calculate the power. The power of the other lamp is 36 watt. Calculate the total energy delivered to this lamp in 20 hours. So power multiplied by time is equals to energy. The power of the lamp is given 36, but the time interval is 20 hours. So you have to convert this 20 hours into minutes first and then minutes into second. What's the final answer in joules? It should be an exponent, big number will be there. So better write in scientific notation or form. 36. Yeah, the final answer for energy, which is power multiplied by time. When too big answer is there, it's better you represent in terms of exponent. So 2.2 into 10 power 7 joules. And how to convert this big number into exponent? On your calculator, you will find this button ENG. Bottom, it's middle left, like on the left hand side, middle of the calculator series, you will find this button ENG. After getting the number, just press this button ENG and it will convert into scientific notation. Another question. A digital watch is powered by 1.3 volt cell. The cell supply a current of 4.1 exponent minus 5 in 1.6 exponent 7 seconds. Calculate the charge that passes through the cell in this time. So formula which relate the charge and current is equals to charge divided by time. So the charge is equals to current multiplied by time. The current which is there in the battery, that is 4.1 into 10 to the power minus 5, and the time, it is 1.6 exponent 7. What is the final answer? 4.1 exponent minus 5 multiplied by 1.6 exponent 7. The unit of the charge is coulomb. So when you will get the answer like 656, that will be in coulombs. Then we need the resistance of the electrical circuit in the watch. So we have the formula V is equals to IR. We have the formula V is equals to IR. V is the voltage, which is 1.3. I is the current, which is 4.1 into 10 to the power minus 5. And R is a resistance. So if it is multiplied, other side it will divide. So it will be 1.3 divided by 4.1 into 10 to the power minus 5. What is the answer? It will be a big number in exponent. You should mention 1.3 divided by 4.1 exponent minus 5. What's the answer? In part A, the current is charge divided by time. So you need a charge, you need Q. So the charge is current multiplied by time. Current is given 4.1 exponent minus 5 and the time is 1.6 exponent 7. So you multiply these numbers, you will get 656. So 1, 2, 3, 4. So 3.1, 31,707 or 3.1 exponent You have the formula in the first one, current is equals to charge divided by time. You are finding a charge. So if you are finding a charge, time is divided, other side time will be multiplied. So the charge is equals to current multiplied by time. So 31 exponent 3 ohms. The next part, output power. So formula for power, power is a product of voltage and current. So voltage is how much? That's 1.3 and current is 4.1 exponent minus 5. So 1.3 multiplied by 4.1 into 10 to the power minus 5. What's the final answer when you multiply these two? 1.3 multiplied by 4.1 exponent minus 5. 5.2 exponent minus 5 or 5.3 of 5 exponent minus 5 watts. So these are the formulas which we use to solve the question related to electrical circuits. Any doubt related to the class? We'll solve more questions related to the circuit. So I'll end the session and share this recording with you.